Unit 1 notes part 2 is about converting from grams to moles or moles to grams, which we actually don't get to in this, but it's the same basic thing, just going backwards. It involves the molar mass. You can look at the start of the notes. It has the molecular weight, the mole, the Avogadro's number. That's all stuff that should be reviewed. The big thing that we're going to use is the molar mass, which is just the mass of the periodic table. Any mass that's on there for any given element is the mass of 1 mole. So we're going to start with a basic conversion. It says how many moles are in 6.07 grams of CH4. In order to do this, you're going to need the periodic table, so make sure you have one with you. Start always by writing out what's given to you. So 6.07 grams, and get in the habit of writing what that's of. So it is CH4. Sorry, it's a little sloppy. Times line. You need to cancel out grams, so grams will always go on the bottom, and that's grams of CH4. And because we're going to get the mass out the periodic table, it's the mass of 1 mole, so 1 mole is up top. To find the mass, you got to find there is 1 C and 4 H's in CH4, so you got to go find the mass of carbon off the periodic table. It's 12. You can round them to the nearest whole number, assuming that they're pretty close. And hydrogen is 1, and there are 4 of them, so that'd be 4 plus the 12 is 16. To solve this, then, you're just doing 6.07 divided by 16. I got 0.379. If you want to call that 0.38, that is perfectly okay with me. But again, get in the habit of units, so it's 0.379 moles. Pretty straightforward. Next, we're going to do a percent composition. Percent composition is also called mass percent. You can see the equation that's there. You're just taking the mass of an individual element in a compound, dividing it by the mass of the entire compound. It doesn't have the times 100. Obviously, that's going to produce a decimal, and to get it to percentage form, you're just going to multiply it by 100. So it asks for what's the mass percent of hydrogen, phosphorus, and oxygen and phosphoric acid, which is H3PO4. In order to do this, we need to figure out what the mass of the entire compound is, and then what the mass of each individual element in that compound is. So it's H3PO4. The easiest way to do this is just do it one at a time. Let's find where am I at right here. There we go. That's a horrible looking H. There are 3 of them. Each of them, when you go to the periodic table, has a mass of 1. So 3 times 1 is 3. For phosphorus, there is 1 in H3PO4 times, we're going to go look, it's 30.97 when you look it up on the periodic table. I'm just going to call it 31 for ease of doing the math. 1 times 31 is just 1. And then for oxygen, there are 4 of them. Each has a mass of 15.999. We're just going to call it 16. And 4 times 16 is 64. So that's the mass of each individual element in the compound. There are 3 grams of hydrogen, 31 grams of phosphorus, 64 grams of oxygen. Total then, so total, sorry, I'm writing like a 2-year-old. 3 plus 31 plus 64, and that is 98 grams total. So then if we're going to find the mass percentage or the percent composition, and like I said, they're interchangeable when you're using them. You first need to figure out where in the world my cursor went. There we go. So for hydrogen, you're going to do 3, the mass of hydrogen, divided by 98, the total mass, times 100. And you get 3.06%. I'm going to do phosphorus next, just because keeping them in the order that I wrote them down. 31 divided by 98 times 100 equals, and I got 31.63%. Since there are 3 and you know that 100% is going to be the total, you have 2 options here. You can either take 100, subtract 31.63, then subtract 3.06 to get that percentage for oxygen, or you can just do the 64 divided by 98 times 100. Either way is going to give you the exact same answer, and that answer, whether you do it one way or the other, should be 65.31%. What mass percent tells us is just the percent composition. So obviously this compound is made up primarily of oxygen, about 2/3 of it is oxygen, about 1/3 is phosphorus, and a very minor amount is hydrogen. We then use those to do empirical and molecular formula problems. An empirical formula is the simplest whole number ratio of elements in a compound. So you can look at the right-hand column that's there, and it has like HO and CH3, lowest whole numbers. You can't reduce that down any further. The molecular formulas, if you look at H2O2, C2H6, both of those are divisible by 2, both numbers in each molecule. So that's what's called a molecular formula. A molecular formula is exactly how many atoms of each element are in a compound. The empirical formula is just the whole number ratio to simplify it. So we're going to go through 2 examples here. One, we're going to solve for the empirical formula, so just that lowest whole number ratio. The other one, we're going to actually go one step further and solve for a molecular formula. Okay. If you notice here, you're given a mass percentage. It's 30.46% nitrogen and 69.54% oxygen. Whenever you're given percentages, just assume that you have a 100-gram sample. The reason why we do that is because 30.46% of 100 grams is 30.46 grams of nitrogen. And then you also have 69.54 grams of oxygen. To solve for the empirical formula, you're going to convert both of these to moles, since moles is the only thing that we can relate between them. So 1 mole goes up top, because we're going to get the masses off the periodic table. So 1 mole there. The mass of nitrogen is 14 off the periodic table. The mass of oxygen is 16. Solve for each of these. For nitrogen, I got 2.18, and that would be moles. And for this, I got 4.35 moles. Now, you're not done at this point. You need to divide by the smallest number. 2.18 is smaller than 4.35, so this is 2.18. Divide there. This is going to divide by 2.18. This is going to be 1. This is going to be roughly 2. It's like 1.99. You ask yourself, are these whole numbers? 1's a whole number, 2's a whole number. So what that tells us is this is our empirical formula. Our empirical formula is for every 1 N, there are 2 O's. And there's our empirical formula. The next problem takes it one step further. We're going to look at MSG. MSG is made up of carbon, hydrogen, oxygen, nitrogen, and sodium. You can see the mass percentages that are there. And the difference between the 2 problems, if you look at this, is this one gives you a molar mass of 169 grams. So what that means is we're going to do the exact same thing we just did in the previous problem. We're going to solve for the empirical formula. Same steps, assume we have a 100-gram sample, convert them all to moles, divide by the smallest number. And then what's going to do is there's going to be one extra step where we're going to have to compare the mass of our empirical formula to the mass of the molecular formula. So again, start out by writing down what is given to you. You have 35.51 grams of carbon. You have 4.77 grams of hydrogen. Again, we're assuming a 100-gram sample. You have 37.85 grams of oxygen. You have 8.29 grams of nitrogen. And you have 13.60 grams of sodium. You're going to convert these each to moles. So look up the periodic table. Grams goes on the bottom. That's 12 per 1 mole. This is 1 gram per 1 mole. This is 16. We've used all these earlier in the notes. This is 14. The only new one is sodium, and when you look that up on the periodic table, it is 22.98. I'm just going to round it and call it 23. So, go through and solve for here. Don't remember these off the top of my head. 2.96. Here, this is 4.77. 2.37. 0.59, and this is 0.59. Alright, so now that we have those, we divide by the smallest number. You have 2 of them that are 0.59, so obviously that's going to be your smallest number. So you're going to divide this by 0.59, divide this by 0.59, Keep going down here. That's 1. That's 1. That's 4. This is 8. And this is roughly 5. All of those are whole numbers, so that means that our empirical formula is C5H8O4NNA. Okay. Now the final step, it gives you that piece about the molecular mass being 169 grams. You have to add up the mass of C5H8O4NNA and see if it equals 169. So this is 5 times the molar mass of 12, which is 60. This is 8 times 1, so 8. This is 4 times 16, which is 64. There's only one nitrogen, so that's 14. There's only one sodium, so that's 23. So 60 plus 8 plus 64 plus 14 plus 23 is 169 grams. 169 is equal to what it says up above in the problem right here. So that means that the formula we have is not only the empirical formula, but it's also the molecular formula.